Hello everyone, good morning.
Good morning, Vikrant.
Let's wait for another 2 minutes. So people are still joining, then we will start. So hello again, here we meet again. So Shrikant sir is in out of office. So today I'm taking the class on one concept actually. So I think I have missed in a previous session. So I need to bring that today. So before into that, so do you guys have any questions or any concern? Very firstly, how was the learning and how was the practice? Is everything going good? Okay, going good. Come on, guys, speak out. So you can unmute yourself. It is not the strict to you should be there on mute only. Don't want to say anything. Okay, so then I'll start my work. So I'll start bring up a one new concept that is outlier. I think I have bring this word earlier as well. So outliers in the data. So do you guys know anything about outliers? Okay, no, I think. So let me share my screen for that. Okay, can you guys can see my VS Code?
Yes.
Yep. So today I'm starting the outlier session today. So what do you mean by outliers? So in statistics, outliers are the data points. Okay, just a second. Yeah, extreme points which affects the data. Okay. Outliers are the data points so that they significantly differ from other observations in the data. This is what the outlier. The data points which stands out from the rest of the points. Okay. So let's assume the data from 1 to 100. Okay. So like let's see, let me tell you how it is assigned, how it is aligned. So like those are um let's say 1, 2, 3, 4, 5, 6. Then at the end, so I can see 100. This is the data we have. So in this data, we have where we can say that we can easily say that we have an outliers in this data. How we could say that? Because we have one data point, we can consider these are the data points. Let's assume so this is a series, this is a column. So we need to identify in the each and every column, do we have any outliers or not? If we have any outliers, some of the algorithms will affect. Let's say if you go with a random forest, or linear regressions, or linear algorithms. So in that case, these outliers may affect. It means it may leads in the wrong predictions, right? So to avoid all of these things, so we should go with how we are analyzed the missing values, right? In the same way, in the next step, we need to take care of our outliers. We need to do some pre-processing of outliers. But it's also the part of pre-processing. Okay, finding an outliers and treating that. How we can find the outliers? So yes, our last class is to a visualization, right? So that's why. So in the same way, I wanted to bring this outliers sections as well. So you can see that. So we have this 1, 2, 3, 4, 5, 6. These data points are in the different same range, right? So we can just calculate the uh, a difference out of each and every data points might be a 1 or 2, right? So it would be in the same range, but the difference between the 6 and 100, these two data points, it is very huge. In that case, we can call this as a outlier. This 100, we can call this as an outlier. It means the data
Uh,
point that, yeah,
when you're sharing something, I mean, we are just seeing the test.python file, the Visual Studio. You're
is it?
sharing something. Yeah.
Okay. I just shared wrong screen, I guess. Let me sharing my screen again. Yeah, can you see it my screen now? Outliers.
Yes, yes. Now it's yeah.
Yeah. Yeah. So here you can see I'm just writing in some data. So 1, 2, 3, 4, 5, 6, and 100. So from here we can say that this 100 is an outlier. Why? Because this data point, this stands out from the rest of the data points, right? So you can just see the what is the range in between each and every data points. It is a small, right? It's the same, not a small. It's the same, almost same. Here it is the same. Some of the cases you might get some almost same. Okay, you might get the difference of 1 or 2 or 100, or if it is a difference of 100 for each and every data points, so all the rest of the point could be in the same region. But here you can see 6 and 100. What is the difference? It's a 94. It's a huge difference. So it means we can call it as this 100 is an our outlier that will stands out of the data. This we can call it as an outliers. So let's come to the definition again. So in the statistics, outliers are the data points so that significantly differ from other observations in the data set. So they can occur due to various reasons. So the in the market, so we will definitely get the data, but it is not in the cleaned format. So you will get the data within a very raw format. So in that data might occurs the outliers because of various reasons. So such as measurement errors. So if whatever the data it is, so measurement error, it could be a data entry error or genuine anomaly in the data. So whatever it could be the reason. So you will get some outliers in the data. You need to check it. Sometimes you may have, sometimes you may not. But better to check first. If you don't have the outliers, that's well and fine. You can just move ahead. But if you have an outlier, you need to treat them properly, right? So how we can treat it? How we can find it? Very firstly, how we can identify whether do we have any outliers or not. Let's see how we can detect the outliers in your columns or in your data or in your any of the data sets. How we can identify. One is visual inspections, plotting the data and visual identification points that deviate substantially from the majority of the observations. Okay, so from the visual also you can do that. I think in the visual section I have told that. So outliers, finding the outliers in the visualization, that is also the part of the data pre-processing. So here that point comes. Okay, just a second. I'll make this as a point. Yeah. Then another one is statistical method. So you need to identify what is the using the statistical technique such as a Z score, which measures how many standard deviation data points is away from the mean. So you need to identify the standard deviations, and from the mean you need to calculate it. So what is Z score? All of these things you may learn in the statistics sections. So Srikanth sir will definitely take the statistics sections. So there you may find different parametrics, different statistical things. Okay. So that is actually the statistical method you can find out. So then a box plots. So observing the data points that falls outside of the whisker of the box plot, which typically represent the outliers. So I will show like how we can plot the box plot and how we can identify. And this is the one of the trending way of finding the outliers. That is a box plots and destiny based projects and machine learning algorithms. So machine learning algorithms you can definitely learn in the upcoming sessions. But so these are the way of finding the outliers. Okay. And once we are identifies the outlier, we need to treatment. We need to start a treatmenting, right? How we can do the treatment and all. Whether we need to removing. So removing the outliers. If you are said like are removing, how we can remove that? And then transforming. If the based upon the outliers level, if you want to transform it into that by converting, bringing all the data into the one standard level, that also in that way also you can remove that. Then imputing and isolating. These are the way of like treating the outliers. Almost all we are getting the outliers in the very far. So that's why almost in all the cases we are just going to removing the outliers. One or two out from the data. So then case we are just removing that. Again, it depends upon the subject matter experts. So those you guys needs to consult those peoples to showcase these are the outliers and like how we can treat them. Whether they said yeah, just remove that outliers, you can just remove it. Okay. Any questions so far? So far so clear? Yeah. So anyhow, you can consider that we are still in that our visualization section, the visualization class. So let's assume that like we'll plot some of the chart to identify uh, outliers. Okay, so let me bring some of data over here. So here you can see, sorry, the data is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 100. So here from this small data, we can easily say that this 100 is a data point that is stands out from the rest of the data. That we can say it as an outlier. That we can say it as an outlier. So how we can identify those outlier from the box plot? So in the SNS, in the Seaborn, we have a method called a box plot. So in that box plot, you can, as usual, you can provide the data. And if you really wants to give the title, X label, Y label, anything, any modifications, you can always open to provide that. But here, our main motto is to identify the outlier by using a box plot. So let me execute this line of code. It's executed. So you can see this box plot. This you can say it as a lower bound, and this line you can say it as an upper bound. So your all the data points will be lying over here. So what is the data? 0, 1, 2 till 9, right? So you can just assume this is from 0 to 20 points, right? So you can say 10 will comes around here, right? Comes around here. It means the data will belong from 0 to 9. The data points will lies on this region in this box. But we have in a point 100, right? So that point lies on here. This is data point. So if your data points is out of this lower bound or upper bound, we can call this as an outliers. Okay, from this chart, we can easily identify, yeah, this data had some outliers. Okay, this is how you can do that. So it's a simple, very simple. So you just need to provide your series of the data. it should not accept the data frame. It will accept a data column. Okay, you need to provide a series or array kinds of data for that. Okay, so this is a small example to identify. So let's go with some big data. So some random data. So here by using that NumPy random facility, I'm just creating a data. Okay, some small set of data. It's not a small, it's having 1,000 rows. Okay, so I'm just creating that with having a random values, random alignment, random assigning of the values instead of me providing a data points. So I'm just randomly giving the data points. Okay, it should give any region, any range of the values. Okay, so this is one of the good example to identify the outliers. Oh, come on. Yep. So I just created that data, that array. So I just converted that array into a data frame with the column name as value. Okay. So here I'm providing that data frame. Here I'm just, yeah, you can provide that data frame as well. So data frame, a figure size I'm defining. So because the data points are very huge, so you may get a bigger plot. So that's why I'm just strict with a figure size. So I'm just providing a title, X label and Y label. So let me execute this line of code. So here you can see some of the data points are lies over here. So most of the points of that 1,000 rows will lies between here, but some few of the data points are lies outside of the upper bound and the lower bound. So we have some points in the lower bound as well and the upper bound as well. So here you can see these data points are outliers. These are the outliers. It might occur, I told it, right? It might occur for various of reason. So those are the mistakes of the data entries, right? So we can easily remove that. So we don't need it. It means those are the false data. So if the data occurs in that way, because that's a human error, right? So you can easily ignore it. How we can easily ignore it? By removing those outliers. How we can remove that outliers? How to remove it? Those data points. Do we need to, so for that we need some reason, right? So we need to say to that Python, right? If we have the data points above this bound or below this bound, to remove that. So we need to give some command. We need to give some command like that to remove those to remove those outliers, right? So let's see what are the techniques we have to remove the outliers. First one is standard deviation method. Remove the data point that falls outside a certain number of standard deviations from the mean. As I told, this is also one of the way of identifying the outliers. By identifying those outliers, you can get the standard deviations and the mean. So you can remove that. For example, you can remove the data points that are more than 3 standard deviations away from the mean. So you can just get that standard deviations and the mean out of that. So if it is crossed greater than 3, then you can remove it. That's also one of the way. And another one is IQR, that is interquartile range. So from the box plot, it is very related. So this IQR, so as we are using box plot, right, identifying the outliers in the same way. So IQR is also the most trending technique to remove the outliers. How we can do that? So IQR is nothing but it's a difference between the first quantile. Sorry, it's the difference between the third quantile and first quantile. Q3 minus Q1. It's a difference between the third quantile and the first quantile. This is what IQR. So we need to identify what is Q1 and what is Q3, and we need to find the difference out of that. So then how to remove the points? So if the data points are false below the Q1, then we can remove it. If the above the Q3, you can remove that. The data points are false below the Q1, above the Q3, you can remove the data points. So for that, you need to calculate Q1, Q3, and interquartile range, and then you need to use the logic like comparison logic, and you can remove those things. So then another one is a Z score. So from the Z score also you can identify it, right? So by comparing the Z score also you can just remove that. If the Z score is greater than 3 or less than -3, you can just remove it, because you might get the outliers from the upper bound as well as lower bound, right? So you can just remove it. So domain specific knowledge again are the machine learning algorithms. So IQR is the only technology which we are using continuously, so that you should aware. So I'm just going with an IQR. So here is the example which I can provide with an interquantile range. Very firstly, we should know the Q1 and Q3. We need to calculate that Q1 and Q3. Q1 is nothing but 25th percentile. Q3 is nothing but 75th percentile. That cutoff region you have that data frame. How we can do that? So we have a quantile method, data frame df dot quantile. So I'm just giving 25th percentile in the sense 0.25 and 75th percentile is nothing but a 0.75. So I just calculated Q1 and Q3. Okay. Once it is calculated, so you need to calculate the IQR. What is the interquartile range? It's the difference between the 75th percentile and 25th percentile. So that is nothing but Q3 minus Q1. Once you find the IQR, then we need to identify the lower bound and the upper bound. How we can calculate it? So this is the formula you should know. That is, lower bound is nothing but Q1 minus 1.5 into IQR. So this 1.5 is a standard number that is derived from some formulas. Okay, so that is again a big statistical calculations behind that to finding this number. So this is a standard and constant number for finding in a lower bound and upper bound. Okay, this 1.5 is a constant. You should not give any other number. If any sort of data it is, you should give the same number. Okay, this is already derived and we have a proof of that. That's actually the theorem. Okay, that is lower bound. So lower bound formula is nothing but Q1 minus 1.5 into IQR, and lower upper bound is nothing but Q3 minus 1.5 into IQR. You need to find out lower bound and upper bound. Now you need to filter out the data frame, right? So less than that of lower bound and greater than, less than that of Q3. This upper bound greater than that of lower bound. That you need to do. So you can see DF less than that of a lower bound. So we are just, I'm just removing. So you can see I'm just using in a NOT operation. So I'm just filtering wherever we have in a data frame that points of lower bound and greater than R, whether it could be if this is possible or this is possible. Okay, DF of greater than upper bound. So lower of the lower bound, greater than of the upper bound. So I'm just removing those data points by using a NOT operation. NOT operation. Okay, axis is equals to 1. Anyhow, I'm providing if you find any data points in the axis 1, it means in the column level. Okay, so I'm just filtering the data frame by removing those data points. Okay, so now I'm just executing this line of code. This day of cleaned is nothing but this is the data frame by removing some outliers, some quantile points. Okay, so now let's plot the box plot again to see whether we have outliers or not. So I'm just using the same code. Instead of passing the df, I'm just passing in a df cleaned. So let me execute this line of code. Yeah, it's executed. You can see we have removed all the data points. If we have like this region, that's fine. But if we should not have a more than that of those values. So this data can give a good performing model than older data. You might not get any errors, okay, while training the machine learning algorithms, but you might get some lesser accuracy of the model. So to increase those accuracy, you need to play around with this sort of pre-processing. Okay, so you can see the data points which we are greater than upper bound and the lower bound, we are removed. How we are removed? By using this interquantile range technique, by identifying the third quantile and first quantile. Any questions so far? Is these things clear?
Yes, sir.
Yep. So this is actually the one of the basic and very needed uh, data pre-processing technique. Like how we have like very firstly we have some data pre-processing, right? Very firstly we need to find out the missing value, right? Then outlier detection, then feature engineering, feature selections. So and what I can say, standard deviation. Sorry, what we can say, data standardizations. So these are the data pre-processing technique that you should do aware. So I think I have explained most of all the data pre-processing. So we have gone through with the missing value analysis, right? So in the next way, we are analyzing the data correlation. By that correlation method, we got to know like how we can extract the important feature of that, right? How we can remove the duplicated columns, duplicated rows, then this outlier technique and the standardizing the data, and right. So you should aware of all of these things. But nowadays everything already got automated. That's fine. But you should know a basic and backend principle how it is working. What is the process to do that? Okay. So I'll just share this notebook with you all. Just have a reference of this outlier section because you might get some interview questions on this as well based on outliers. You might get some questions like what is outliers, how we are going to identify the outlier, what is interquartile range, what is Q3, what is Q1, what is the formula for lower bound and upper bound, and what are the techniques to remove that, right? So IQR is also one of the technique. If it comes to the IQR, how you are going to remove it. So these are all questions you might get in your interviews. Yep. So any other questions do you guys have? Yep. So with absence of Srikanth sir, I take this a small concept and I'll just explain. Maybe he also can he explain bit on that. But on that time you can just say Vikrant already taken this outlier section might be. So you can just continue with the other sections like other statistics. So we have a lot more things to you guys have a lot more things to learn. So this outlier is also the one of the things which I showed. Okay. If you guys have any other questions, if you have any other subject to discuss, come on guys. Did you get bored? Did you guys get bored? Yes, sir.
No, sir.
Okay. So it's actually the very interesting topics actually. Like if you go with this small set of topics, right? So you might get a good understanding of that. So here today I just explained the outliers. So you can just start researching on what is outliers, like how it could be. So I just given examples, right? This is the data, this is the data point. And you may also try with some different data set. As I told, right? So in the Kaggle, you might get ample, like millions of the data sets in the Kaggle. You can just download it, read it, and just try to plot a box plot at least. Try to identify whether do we have an outliers or not, how we can remove it. So in this way, you guys get familiar with the subjects. Okay. So nowadays machines can do all this identification, outliers removing, everything can do. But you guys should know a backend principle of that. In the interview definitely they will ask, but in the regular work you might not get a chance to look into this. Okay, so far so clear.
Yes, sir.
Uh,
Yes, then
I
I'll take a pause. Yeah,
I have a question regarding the data frame.
regarding
Regarding the data frames.
okay data
So
frames. Okay, what is
yeah.
that?
So uh, like what should be the ideal method when we are fetching the data into a data frame and then doing the filters and
Hmm?
then in the final data frame, we are adding some more columns as a constant,
Hmm?
or maybe we are computing some values and appending to our data frame.
Hmm?
So what should be the ideal approach? Like,
So what is the what I can say? What is your goal actually?
my goal is to, to write the data back, to, to fetch the data from source, okay,
Hmm?
do some computations, apply
Hmm?
some filters,
Hmm?
then uh, like since the source is multiple, okay,
Hmm?
so from multiple sources I'm computing something and putting into a variable, and now those variables I need to append to a data frame, okay.
You need the
So
data back.
yeah, so in this case what should be the ideal approach?
Yeah, anyhow, but trust me that filters will take some time. Okay. So
Hmm.
if the data is big, it will take a good amount of time to filter the data because it is going to check each and every rows whether it is there or not. But be sure that if the data is less, if the data is big, the filter will definitely will take the time. So then other thing is how you are applying in a filter, that also matters. You are going to apply in a multiple filters, in that time also it is going to consume a good amount of time. But so first you need to fetch the data, then you can filter it. So before that you need to save the data. Whatever the data you have, you can just have a copy of that. Then filter it. So once you have filtered the data, okay, anyhow you are going to create within a different variables, right? So let's say here I'll show that. So here you have, let's say you have a data frame. Okay. Then what happened after the filter, df filter, you are creating in a variable, different variable name, right? Df
Yes.
of and df this column, whatever the column equals 1. So you are just filtering it, right? So anyhow you have your older data, you should not have any copy of that. You can just filter that. If this is a filter data frame, you have the both the data frame, right? So after that, once that is done, so you can also have, so in this data frame itself, in the data frame itself, if you want to append the unfiltered data as well. So if you are like here equals, here you are getting equals 1, then means so you are just leaving the values if not equals to 1. So you can have the copy of that as well by using not. It means the reverse. You got my point, right? If in the case it is not equals to 1, the data points is not equals to 1, you may have the copy of that data frame, and at the
Now,
end you might get the data back.
now consider one more variable, okay,
Hmm?
where I'm computing some count. Okay, let's say v count is having some data. Okay,
Hmm?
now that v count I have to append to a data frame, the
Hmm?
existing df filter.
Okay. So you are going to append the df count within a df filter.
Yes, yes,
Uh, how it could possible? So you need to have a count of df filter and then appending it, right?
yeah, yeah.
So then like we can say the shape is different. So
No, no,
you are
I am
just going
appending one more column in df filter,
hmm,
and then I am publishing it to the data source.
publishing into the data for, yeah. But so you are just like, if the count column is having the same values, okay, so you are just creating in a count column, okay, for the data frame. Instead of creating there, if you need the data filter at the end, you can just create a count column for the df filter itself. After filtering, you can just add that column instead of adding at the very beginning.
Okay, okay.
Yeah, so instead of like at the end you need this df filter only, right?
Yes, yes, and then df
Yeah.
filter.
Yeah, so then why you need to have the count column over here? You can just have the count column over here. So you need a df filter with a count column. Then in case you can just add the count with a df filter only. Unnecessary why you are like increasing the memory of this data frame. These things will matters if you are using a big data. If
Okay,
the small data, that's fine. That memory occurrence is very less. But in the big data, these small things also matters.
okay, okay.
Yeah.
Thank you.
So I think, yeah, if you don't have any other questions, so let's close this call. Maybe tomorrow onwards, we'll start with some other topics, that is statistics and machine learning algorithms. Okay, so until that time, have a great day. Take care. Bye-bye.